then various messenger related RNA, and then epigenetic linked things are evolving in the field. So the vaccines, what we had in the COVID pandemics is actually based on a sort of siRNA system, which is again encapsulated in a specific cargo system, which is actually we can call it as advanced drug delivery system. Next slide. So we need various sorts of requirements for modern drug delivery. So that includes site-specific release of active pharmaceutical ingredient. For example, if you take any implant material or dental prosthetics dedicated for specific medicament release, you may have to embed or modify the surface with various growth factors. If you take bone implants, tissue engineering grafts, you may have to load various growth factors such as vascular endothelial growth factor, recombinant human bone morphogenetic protein. These are the two examples very often people use in bone related implant materials. So how to characterize those? So routine drug release analysis can be done in spectrophotometric analysis. So if I embed protein or other anti-inflammatory controllable moieties for making the sample preparation, analysis, and readout interpretations. And targeted drug delivery, especially in gene therapy, is very, very essential to avoid toxicity, genetic toxicity. So oral drug delivery also, especially with small molecules to peptide drugs, also complicated. For that, we need modern analytical techniques. And especially when you think about crossing blood-brain barrier, you need, of course, lesser dimensions which can penetrate our blood-brain barrier system. Say, for example, less than 5 nanometer or 10 nanometer of cargo system. To characterize that, you need angstrom level morphological characterization or size analysis, right? So that you can ensure the size exclusion or inclusion criteria of specific active pharmaceutical ingredient. So how to do that? For that, you need sophisticated technique. For example, electron microscope, atomic force microscope, Raman spectroscopy to see the surface functional groups, and many other vibrational or non-vibrational technique in addition to routine pharmacokinetic or pharmacodynamic analysis when you talk about drug delivery system. And long-term treatment for chronic diseases also deserve sustainable release systems. For that also you need advanced analytical techniques. So these are simple examples, case examples for requirement of modern analytical systems. So let us have a case example related to stimuli-induced size tunable strategies and applications. I believe Professor Subramanian sir might have talked about light-induced. Yes. Yes, sir. Light-induced. What is meant by light-induced drug delivery? So controlling the release using light, right? I just saw that contact, I think 60% related to that. So how to control the release with the light? The material, the cargo system should respond the excitation wavelength and alter the shell or release kinetics according to the light. So imagine this is a complete ICU system. We are all handling microbes or contaminating substances. I want to disinfect this. There are many ways, right? We can fumigate, we can use disinfectant. Instead of doing that, if I have a light active, photo irradiation active wall paints, I just have to turn on the UV light or other visible light by which I can create reactive oxygen species on the surface by which aerobic bacteria can be killed. Modern advertisement claim the same, right? Yellow paints or whatever other wall paints having silver nanoparticles which can release metal ions by which the aerobic bacteria can be sucked and then killed. So there are different sorts of mechanism of action for individual release of metal ions in aerosol form or surface contact. So, when you talk about the stimuli responsive, there are various stimuli responsive factors by which you can control the release profiles. For example, pH. Whether the pH of normal cells and cancer cells are same. Cancer cell is what? Normal cell, but in abnormal growth, right? So obviously their extracellular matrix, physiological component, genetic information will be altered. So their pH is also different. When you have wound, your acute wound and chronic wound will have different pH. When you have cytokine release at the wound site, your pH will be increasing. The healing markers will based on the release of cytokine markers at the surface. So when you have pH dependent drug release or release of shell, or shrinkage of shell, then you can control the drug release. For that you need pH meter. So you cannot put the pH meter on a small one, right? You need a probe system by which you can control the intravenous or in vitro external. For external analysis, it is very easy. You can put pH paper, see the thing. But when you want to study about septic conditions, internal, intravenous, in vivo analysis, you need microelectrodes or the kind of dye by which you can analyze a particular site where the various pH of wound related stuffs can be analyzed. So pH is one such example. Same way enzymes, ionic concentrations, temperature, and similarly electrochemistry, that is redox behavior by which you can actually control the release of drugs. So you can see various pictorial representation how one drug release can be achieved. So depends on each analysis, the characterizing equipment or analytical techniques may vary. So what are the different aggregation strategies by which you can control the release, that is click reaction in the case of enzymes, for example cyano 1,2 thialaminoacid alkyl amine and acyl reactions for enzymatic induced analysis, and pH of course, Zwitterianic behavior, proteins very often exhibit Zwitterianic behavior. And when you talk about light, these are the functional groups very essential for cleavage or fusion. So you need a surface analytical technique to probe these functional groups exist in the cargo system before and after interaction of active pharmaceutical ingredient. So when you have temperature controlled release, these are the case examples. PPC, polypropylene, caprolactone, polyamide, and PDEA, polyethylene oxide, polypropylene oxide, polyphosphate esters, various other things, PLGA, PVP, many other examples. Of course, in electrochemistry, quick reactions and post-gas interactions. For example, 1 electron, 2 electron transfers is very common in ferrocene redox mediators. So this is one pictorial representation showing electrode with self-assembled monomers of subpolymers. So with respect to different solvent conditions, ionic conditions, these polymer brushes can be collapsed. So when it collapses, the active ingredient embodied or blended within this matrix can be released into particular cell. So people nowadays talk about swallowable capsules, where redox mediated triggered release of drugs can happen in your stomach at particular site. Next one. So this is the basic potentiostat or electrochemical system where various conventional electrochemical characterizations can be done. So this is the glassy carbon electrode. You can see at various dimensions, and this is the modern disposable electrode system similar to glucometer analysis cartridge, having different layers by which the whole blood is passivated by protective layers and then interacting into the active surface where enzymes are exhibiting a specific oxidation or reduction reaction to measure the glucose concentration. So you can see with the multiple electrode arrays, one can distinguish polymicrobial existence or different. For example, even if you take COVID pandemic situation, there are multiple leads, drug leads. I have 5 heterocyclic compound of different derivatives. 5 is potential for anti-inflammatory or antimicrobial application. I want to see the pharmacokinetic specific binding constant or dissociation constant or ICP value or IC50 value for this particular drug. So when you have electrochemical based protein-protein interaction or drug-protein interactions, so if you have 5 different working electrodes at a one stretch, you can measure the protein-protein interactions of 5 different drug molecules and find out Kd or Ka value for individuals. Instead of doing isothermal calorimetric analysis or any other conventional assays, electrochemical based method of analysis can be done. So the advantage of electrochemical system is response time is very rapid. So when you put 1 drop of blood, you are seeing number within few seconds, right? So the analytical response time is very often less than 1 minute and can be flexible. And so it can be integrated on wearables. Now many are wearing smartwatches, right? The same way, textiles can be embodied with flexible electrodes, by which sweat containing lactose, glucose, salt analysis can be done. So athletes having different abnormalities when they are in a particular illness can be monitored on real time. Of course, with the machine learning, Internet of Things, and many other emerging artificial intelligence tools, all these abnormalities can be monitored in a regular manner. Of course, reduced assay cost, which is actually little complicated, based on evolutions of materials and techniques or method of analysis. This can be controlled. Next slide. So let us have brief information on fundamentals of electrochemistry so that the case examples will be very easy for you. So far is everything okay? Any doubts? Any doubt? No doubt? Are you guys following me? So electrochemistry is around us. It's in automobiles such as batteries, fuel cells, supercapacitors, sensors. So we have electrochemical reactions within our biological system in terms of respiration, ion channels, fermentation, photosynthesis if you take plants, and corrosion, especially concrete corrosion, rust formations in steel substances, specification layer, cathodic, anodic productions. These are the terminologies you might heard in many other occasions, but the inline principle is electrochemistry. And displays such as electrochromic windows. So you people sometimes have spectacles with sunlight and dark light. It switches, right? So that is called electrochromic. And conducting polymers. So with respect to different conductivity, polymers can also show different sorts of colors. Of course, fuel cells, the modern hydrogen fuel cells, aerospace engines are also working on electrochemical principle. So basically, two things happen in electrochemical cell system. One is oxidation and protection system. So that may be triggered from the electrolyte or it may be happening from the electrode surface. Very simple. Next slide. So this is the conventional setup. 3 electrode system. Very often people use for understanding the basic electrochemical problem. For example, if I have andrographite, what is andrographite? So what is the active ingredient in Nilavembu Kudinir? Answer solution. So same. So Nilavembu Kudinir is not for anti-dengue, right? So Andrographis paniculata, that is the plant species winter queen, which is used for anti-dengue treatment. So the active ingredient or phytoconstant exists in Andrographis paniculata is andrographite. So if I want to quantify andrographite in Nilavembu Kudinir, For example, I want to first see the functional groups which can oxidize or reduce at the electrode interface. You may ask to do electrochemical characterization of drugs, whether it is synthetic or chemical or semi-synthetic natural product. Does it really require oxidizing or reducing functional groups? Not necessary. Sometimes even liquid-liquid interface, say some sort of ion pair coupled transition. Through that way also you can quantify the active release of that particular drug molecule on various mediums. So this is the conventional electrochemical setup showing working electrode, reference electrode and counter electrode. So working electrode is the actual substrate where the oxidation or reduction reactions will be happening. Okay. For example, we have two walls that go under. So this is the potential window. Working electrode will be swept with this particular distance. My material will be oxidized here or and again reduce at some other potential. So monitoring the oxidation potential and reduction potential within this potential window with respect to applied potential, that is reference potential. That's the basic voltammetric technique by which many people do oxidation or reduction reactions of potential materials. So these are the various techniques. For example, cyclic voltammetry. So I mentioned two potentials. This is the anodic potential and cathodic potential. So this is indicating the oxidation reaction and reduction reaction. And this is the linear shift voltammetry, which is the only one forward scan of this particular technique, and pulse voltammetry technique, which is again discussing the Faraday process alone. So for any electrochemical thing, you have to understand Faraday principles as well as Ohm's law. So that is the basic governing all these principles. And the commercial application related gadgets are often relying on chronoamperometry and electrochemical impedance spectroscopy. Chrono means time, amperometry means current. With respect to time, you are measuring the current variation. So this is the basic principle happening in glucometer. And other techniques are based on electrochemical impedance. Impedance means ampering, restricting. So the movement of drug molecule from one potential to other potential can be depends on the amount of barriers exist. If there is no chance, I can run fast, right? If multiple chairs are there with multiple occupants, then my movement will be restricted. So the rate of movement or the flow of electron from one surface to electrolyte or electrolyte to electrode surface is the impedance measurement, by which you can see the charge and transfer resistance. If it is high, it is conductive. If it is low, it is insulating. That's the basic concept in electrochemical impedance spectroscopy. So these are the varieties of techniques very often people explore for analyzing any sorts of drug or drug delivery system. So I'm going to now the case studies or examples of modern drug delivery system and how electrochemical techniques have been explored for analyzing those systems. So this is one sort of work that discusses the combination of methylene blue modified on molybdenum trioxide nanosystem. So one of my project in CSIR3 is to develop antioxidants as well as a redox active system for theranostic application. What is meant by theranostics? Theranostics indicates the two terminology. One is therapeutics and diagnostics. Okay, therapy plus diagnostics is combined into theranostics. So I want to develop a material which can be useful for both therapeutic as well as diagnostics. So if I want to use for diagnostics, it should exert two properties. One is imaging property or sensing the molecule through electrochemical technique, because that's the basic principle or vision of our institute. So I want to develop the electrochemically active or optically active material through which I can use the development system for healthcare applications. And the therapy is antioxidant or anti-inflammatory. So that was my motivation. So when we look at various systems, we came to know that molybdenum trioxide is a FDA approved micronutrient for various clinical conditions, as well as it also exhibit antimicrobial, antioxidant property. So we synthesized molybdenum triazide nanosystem through our own laboratory protocol and modified methylene blue on the surface of molybdenum triazide. So through methylene blue, we exerted imaging property, fluorescent property, and molybdenum oxide is exhibiting the antioxidant property. So when we see methylene blue alone, it leaches very fast. So it has a cytotoxicity, uncontrolled release, having cytotoxicity issue when we talk about in vivo application. To circumvent that, we modified the methylene blue on molybdenum triazide and we performed the various characterization to ensure their viscochemical property and biological property. So this is the schematic representation of fabricating this molybdenum triazide methylene blue. You can see atomic force microscopy showing the nanostructures of the particles, and this is the transmission electron microscope image of the nanoparticles. And you can see this is the toxicity study which we have done with the Selenium Hepatitis elegans, which is the soil nematode worm, very emerging materials. The genomic information are similar to humans, so whatever we study with C. elegans, it can be correlated for mammalians. Next slide. Help us to estimate why we use C. elegans with this next slide. And these are the other materials. So you can see molybdenum, methylene blue, and methylene blue when it is treated with the C. elegans, their scavenging ability, ROS scavenging is comparable with the or better with the control drug that is resveratrol. So this is how we have quantified the antioxidant ability of this particular system. So this nano system is act like both imaging probe as well as scavenging system. Next slide. So based on that inspiration, we also used similar sorts of fluorescent active material as well as the redox active system to modify on another material named ruthenium chitosan. So you see molybdenum triazide here again exhibiting the same antioxidant property, and chitosan is a biopolymer derived from chitin deacetylation process. So we have modified the molybdenum triazide with the ruthenium bipyridine, which is a metal coordination complex exhibiting both electrochemical property as well as imaging property, which was further modified with the chitosan to enrich the biological compatibility with the model system, and we have performed both worm survival study indicating the cytocompatibility as well as fluorescent imaging with the material alone. So interestingly, we also performed the electrochemical property for ensuring their sensing application, for which we have taken a polyphenol as the model drug system named Beauty, which is chalcone type of polyphenol. So this is the electrochemical characterization of this particular drug delivery system, which was probed with the model drug named Beauty. As I mentioned, butene exhibit catechol type OH groups, which is known to oxidize into guanine at this particular potential. So when we increase the concentration of this particular drug on the analyte sensor substrate as analyte, so with respect to scan rate, the oxidation and reduction reactions of this particular drug is increasing proportionally. So with that phenomena, the specific anodic potential was applied in amperometric methodology by which we have quantified the various concentration of analytes. So imagine this molybdenum ruthenium chitosan is modified as a kind of solid implantable surface with the embodied drug Beauty. If this particular patch or bandage is applied on epidermal surface for wound healing, this butene release can be electrochemically or electrically modified because butene is electrochemically active, and it can be undergo imaging also in case of implantable systems. So this is the three mechanism of actions or functions exhibited from single system. So ruthenium provides electrochemical property. This butene as a model drug is electrochemically active, by which electrochemically you can monitor the drug release from the base substance. So these are the conventional in vivo analysis by which you are correlating the antioxidant or radical scavenging property of the fabricated system. For any sensors, if you want to climb for real-time analysis, what is the linear range of analysis? What is the detection limit? What is the sensitivity? Those are the very common parameters you have to report for any development. So on that note, we have also determined the detection limit. So this particular system is capable of detecting butane drug molecule in the range of 28 nanomolar. So that much low concentration in particular test samples, this particular analysis can be performed. And wide linear range of analysis. That is also possible with electrochemical system of analysis. Next slide. So the next recent work we have done in our laboratory, especially during the COVID pandemic situation, is developed the sensors for interleukin 6, IL-6, which is very common in cytokine storm, especially with the COVID. So this interleukin is a very common probe for indicating a person that he or she is suffering from inflammatory disease, including COVID. So we have developed a molecular reaction as the base sensor platform, which was further modified with the camphorol, which is again a sort of polyphenolic derivative. So interestingly, this also exhibits redox behavior. We have modified the molybdenum trioxide with the camphorol and explored their function as of antioxidant as well as electrochemical immunoprobing of interleukin 6. So immunoprobing is nothing but monitoring the antibody antigen interactions. So IL-6, as I mentioned, is an important marker for inflammatory disease. It can be overexpressed in serum as well as in plasma. So we have taken this particular system and modified on electrode surface and studied that for immunoassay of interleukin 6 from analyte samples. Next slide. So these are the various analytical technique. I'm sorry, because of poor light, the slides are not visible. But you can refer the published paper, which is available in Materials Today Chemistry. So this is the TEM image, transmission electron microscope, which not only describes the surface morphology but also surface shape distributions of this particular system. It also has elemental mapping. For example, molybdenum oxide has molybdenum and oxygen. So when it is modified with camphorol, obviously carbon, oxygen, and hydrogen are available. So elemental level analysis also we are able to do it. Sort of advanced analytical technique for modern recurrent system. And this is again X-ray photoelectron spectroscopy, which is similar to other vibrational techniques such as FTIR or Raman spectroscopy, by which you can discuss the functional groups. Since camphorol is interacting with the molybdenum hydroxide, which hydroxyl group is forming intermolecular hydrogen bond with the molybdenum trioxide. So metal and organic bonding that can be determined using this X-ray photoelectron spectroscopy. Similarly, we also perform the X-ray absorption spectroscopy. Can you go back to the previous slide? Yeah, that scheme previously. You see here, it's camphorol molecule, and when this particular molybdenum trioxide is interacting with this particular hydroxyl group of camphorol, there is an interatomic radial distance variations happening in the molybdenum trioxide. So, for example, one camphorol interacting with the molybdenum trioxide, there is, if I just hit this, it will just move, right? So the interatomic radial distance was determined in X-ray absorption spectroscopy. Next. So based on this interatomic radial distance, the bonding between molybdenum oxygen and molybdenum is varied. So that information we have determined and reported in the particular work for the first time. Next time. And there are lots of cytocompatibility analysis like MTT assay and radical scavenging assay using thiophoric acid and dichlorofluorosine diacetate assay, which are all indicating the antioxidant property of this particular system. And we also perform the EPR, electroparamagnetic resonance spectroscopy analysis, by which you can quantify the radical scavenging ability of this particular antioxidant. So you can see with respect to dose, the radical scavenging ability of this particular system is very high. So when cells under stress, if you give this particular drug molecule, it can control the RBS species, by which exerting the antioxidant property. And similarly, this material exhibits the synergistic property of immunosensing. So that's the prime goal of our one other application. So as mentioned in the earlier slides, we have modified the working electrode surface with this particular material, which is capable of exerting anodic and cathodic reactions, that is oxidation and reduction reactions. So when you modify monoclonal antibody, the specific target can actually undergo immunocomplex formation. So when antigens and antibodies bind through paratope and epitope interactions, there is a biofouling layer happening in the electrode surface. So which may hamper the inherent oxidation or reduction reaction from the underneath electrode. Through that probing, we have quantified the analyte concentrations at the level of femtomolar. What is meant by femtomolar? 10 power minus 9 is what? 10 power minus 12 is pico. 10 power minus 15 is femto. So that much level of ultra low analyte concentration sensing can happen in electrochemical system. And we have reported the active surface area, which is redox active, small area. So in simple, electrochemical based technique can be very useful for not only in vitro analysis, also for in vivo analysis, especially for ultra low release. So if you want to specifically focus single cell or cancer target site, the specific release or genetic level control of particular critical system can be monitored using electrochemical cell. So that's the case examples I wanted to present. So this is my final technical content slide. So what is the challenges or opportunities exist in this particular field? I believe I have introduced you electrochemical based approach and modern advanced drug delivery system existed for antioxidant or anti-inflammatory applications. So for any drug delivery system, biocompatibility and acceptability is the prime requirement, for which the material, whatever you imagine for development, should be eco-friendly or bio-friendly. And lack of animal models for brain drug delivery system. In case if you are interested in toxicological analysis, pharmacology or other things, addressing central nervous system, especially brain, in case of neurodegenerative disease or tumors in brain. So crossing blood-brain barrier, so fixing models according for that is very difficult. So in one way it's a challenge, and the other way it is the opportunity. And toxicity profile of novel composite cargo materials. So if I want to publish a paper, or if I want to bring a new product into market, obviously people will think about new materials, right? So when you develop new material, you never know what is their toxic profile. So we now came to know Teflon or bisphenol alcohol, BPA. Saldar but I came to know that the BPA released from plastic is the one of the concept, right? So bisphenol alcohol. Same way, actually, fluorinated BPA or other phenol derivatives are used as the pickling agent or plasticizing agents in plastic industry. You may never know the toxic profile of BPA alone reported in FDA report. But the emerging material may also have same sort of neurodegenerative markers. We may not know. So understanding the toxicity profile of emerging material is very important. For that, various institutions are providing toxicological analysis. So when you develop new drug delivery system, always focus about the precursor agents and personalized therapeutics with ultra precision and accuracy. So whatever drugs we are developing, on a general note, is working for anti-cancer activity. Doesn't mean it exhibits the same sort of property in Caucasian family, African family, or Asian family. With a different ethnicity, their pharmacological functions or epigenetic role may vary. So personalized therapeutics with ultra precision and accuracy is very important. Same way, short half-life, fast metabolism, and rapid elimination are challenges and opportunity for optimal drug delivery development. And limited therapeutic efficacy of monotherapy. So what is meant by monotherapy? So to develop better bioavailability or exhibit better biological functions, synergistic effects are required. So when you synergize with other components, you don't know the combination effects, right? So understanding those therapeutic efficacies also challenges are opposite, and not specific distributions to healthy tissues. That is also one of the other prime challenges in drug delivery development. So these, in my understandings, are the challenges and opportunities. So as I mentioned, CSIR is one other national important institute similar to IITs or ISIS or other institute. Distinct from those MHRD institute, CSIR is kind of industry-oriented institute where large amount of R&D is the main focus than teaching. We do have teaching programs like BTech, Chemical and Electronic Engineering Institute. Similarly, in Leather Research Institute, they do have BTech in leather technology. CFTRI, they have food-related courses in Mysore. So in city, we have lots of R&D facility on payment basis. Also, people can perform their dissertation work. In past, people from I think other pharmacy colleges also visited our institute for skill development program to learn the advanced instrumental techniques applicable for their. So in case if you are interested, you can visit this website cecri.res.in. I have given this PPT to principal sir. So any of you interested, you can visit him and refer the pages. And also R&D instrumental analysis available for various characterizations can be seen in the R&D output or R&D infrastructure tabs. Next one. So many people, whenever I go for talks, ask for opportunity. The entrance itself, I have seen pharma tree, lots of scope. I have seen various things, but some other institutions are still can be added. So one example is, as I mentioned, the Central Institute of Medicinal and Aromatic Plants in Lucknow, CMAP, is known for various pharmacognosy or natural product related isolation and formulation development. And yet another institute in Lucknow is Indian Institute of Toxicological Research, where all sorts of cytotoxicity or animal toxicity related analysis for novel formulations can be performed. And same way, Central Drug Research Institute in Raipur, in UP, and one more institute in Palampur. So ISPT, Indian Institute of Institute of Himalayan Bioresource Technology in Palampur. So these are the famous pharma-related CSIR institute where pharma people can find scope in sort of project assistant or project associate or integrated PhD fellows based on the CSIR or funding related opportunity. For example, I have DST, DPT and SERP related fundings where I can recruit project assistant. Then they may be after qualifying the requirement related to fund availability or project assistant experience can register for either integrated dual degree PhD or direct PhD. Or with the project assistantship also you can find sometimes technical post. So these are the various institutions from CSIR where you can find employment opportunity. So that's all my content. I wish to present my sincere thanks to my parent institutions. I did not put my undergraduate institute. I did not find the last minute time to restructure, but I'm very grateful to my undergraduate institution, Goa Medical Center and Hospital, where I happen to have motivations through my seniors to reach various places. So I did my master's and PhD as a person mentioned in South Korea and moved Canada for postdoctoral training. So with various funding agents, support from Government of India and private organizations, I'm doing my best to bring something for societal benefit. So thank you so much. If you have any questions, I'll be very happy to answer.